Hello everyone. In today's presentation, let us discuss about the applications of an operational amplifier as an integrator and the differentiator. So now let us discuss about integrator circuit. In an integrator circuit, the output voltage is the integration of the input voltage. Op-amp integrator circuit is as shown in the figure. This op-amp integrator circuit uses a capacitor connected between the output and op-amp inverting input terminal. So here in the circuit, input voltage Vin is applied to the inverting terminal of the op-amp and non-inverting terminal is grounded. Now from the circuit, the potential at node B, VB is equal to 0, and from the concept of virtual ground, two input terminals are at the same potential. So therefore VA is equal to VB is equal to 0. Now from the circuit, current I1 is equal to Vin minus VA divided by R1. We know that VA is equal to 0, right? So current I1 is equal to, therefore I1 is equal to Vin by R1. And we know that charge across a capacitor Q is equal to C into Vc. So now current through the capacitor IC is equal to d by dt of Q, right? That is rate of change of charge is equal to current. So here IC is equal to C into d by dt of Vc. Now using that here in this circuit, here we can write IF as CF into d by dt of VA minus V0. And VA is equal to 0. So IF becomes CF into d by dt of 0 minus V0, which is equal to minus CF d by dt of V0. Okay, so now since the op-amp input current is 0, current I1 flows through the capacitor CF as IF. That is I1. That means I1 is equal to IF. I1 is equal to IF. So here I1 is Vin by R1 and IF is equal to minus CF into d by dt of V0. So therefore dV0 by dt is equal to minus Vin by R1 CF. So now integrating both the sides with respect to t. So integration of d by dt of V0 dt is equal to minus 1 by R1 CF, okay, constant, integration of input voltage, that is Vin dt. So therefore output voltage V0 is equal to minus 1 by R1 CF integration of Vin dt. This shows that output is the integration of the input voltage, and here the term minus 1 by R1 into C1 indicates the gain of the amplifier. Okay. So now if input signal is a square wave, then we are going to get a triangle wave as an output in the integrator circuit. So this is about integrator. So now let us discuss about differentiator circuit. In a differentiator circuit, the output voltage is differentiation of the input voltage. A differentiator circuit using an op-amp is as shown in the figure. Here, this circuit uses a capacitor in series with the input voltage, and input voltage is applied. It is applied to the inverting terminals of the op-amp, and non-inverting terminal is grounded. So again, from the circuit, the potential at node B, VB is equal to 0. So from the concept of the virtual ground, the two input terminals are at the same potential. So that means VA is equal to VB is equal to 0. So now from the circuit, current I1 is equal to C1 into d by dt of V in minus VA, which is equal to C1 into d by dt of V in minus 0, because VA is equal to 0. So current I1 is equal to C1 d by dt of V in, and the feedback current, that is IF, is equal to VA minus V naught divided by RF. And we know that VA is equal to 0, right? So 0 minus V naught by RF is equal to current IF. So IF is equal to minus V naught by RF. And again, since op-amp input current is 0, current I1 passes through the resistor RF as IF. So that is I1 is equal to IF. So I1 is C1 d by dt of V in, and IF minus V naught by RF. So now rearranging the term in this equation. So after rearranging these terms, we are going to get the output voltage as minus RF C1 d by dt of V. And this shows that output is the differentiation of the input voltage, and the term minus RF into C1 indicates the gain of the amplifier. So now, for example, if the input voltage is a sine wave, then the output of a differentiator is a cosine wave.